In this data structure class, we will see the selection chart from third unit, searching and sorting. In today's class, we will discuss the definition of selection chart. After that, the working principle, that is the algorithm of selection chart. And then we will see some of the examples for this selection chart. And finally, we will discuss the advantages and the disadvantages of selection chart. First, let us see the definition of a selection chart. The selection chart, it orders a list of values by putting smallest value in its correct position at every iteration as per the following step. Okay. The step 1, find the smallest value in the list and switch the smallest value with the first position. Okay. See, in the unsorted data, it finds the smallest value and the smallest value will be replaced to the first position. Okay, the value first position will be replaced here. Okay, these two items will be switched between each other. Okay, and second one, it finds the next smallest value. For example, it may be here, and that will be replaced in the second position. Okay, hence it has two sections. The first position is sorted list and second position is unsorted list. Okay, so at every iteration, the sorted array is get incremented one by one, and unsorted array size will get decremented one by one. Okay, until it sorts all the data places, that is data points in its right place. Here, these are the given set of values to be sorted, and the corresponding index is given. See, the index should always start with 0, and total we have 8 items, hence the last index is 7. Okay, 8 minus 1 is 7. Okay, and which is the first step? Find the smallest element in the array. Okay, and that smallest index should be stored in the integer value min index, that is minimum index value. Okay, see, in this array, which is the smallest value? 1 is the smallest value, right? So, in min index, 1 will be stored. And the second point, exchange it with element in the first position. In the first position, which data item is there? 27 is there. Hence, this 27 and 1 will get exchanged. See, at end of pass 1, 1 is placed in its right position. 27 is here. Okay, and which is the third step? Find the next smallest element. See, in this list, which is the next smallest element? 9, isn't it? So 9 is the next smallest element. Hence, the 9 will be exchanged with the second position. Okay, in the second position we have 63, isn't it? So this 63 and 9 will get exchanged. Okay, 9 will be located in its right position at second point. That is second pass. Okay, 63 will be placed here. Okay, and next smallest value is 14. Okay, that 14 will be replaced with this 27. Okay, so at the end of third pass, 14 will be placed in its right place and 27 will be exchanged here. Okay, and this steps will be continued until all the data elements will get sorted. Okay, this is the fourth step. Now let us see one example for this selection sort. Sort the given set of values by using selection sort. The given values are 8, 4, 6, 9, 2, 3, 1. Okay, the index are 0, 1, 2, 3, 4, 5, 6. Okay, which is the first step? We need to find the smallest value in the list. Okay, see which is the smallest value? 1 is the smallest value, and we need to exchange the first position value 8 with the 1. Okay, see, the 8 will be replaced with the 1. Okay, so at the end of part 1, the smallest value will get its right position. And next step, we need to identify the next minimum value. Which is the next minimum value? 2 is the next minimum value, isn't it? So now 2 should be replaced with the 4. Okay, see, 2 will be placed here and 4 will pass 2, the second lowest value will get its second position. Okay, now which is the minimum value? 3 is the minimum value. Okay, 3 is the next minimum value. Now 3 will be exchanged with the 6. Okay, that is, see, 3 will be exchanged with 6, and these two items are exchanged. So at the end of pass 3, the third minimum value will get which got its right position. Okay, now the next minimum value is 4. Now this 9 and 4 will get exchanged. See, 9 and 4 will get exchanged. So this is pass 4. Pass 4. And next minimum value is 6, right? So the 6 is next minimum value. Now these two values will get exchanged. See, at the end of pass 5, 6 is placed in its right position. Okay, and the next minimum value is 8. Okay, see, at the end of pass 6, 8 is getting its right position, and the 9 is the last one, and it is actually placed in its right position. So this is pass 7. Okay, so it takes 7 passes to sort all the data items in the list. Okay, now let us see another example, that is sort the given numbers by using selection sort. Which are the numbers? 23, 78, 45, 8, 32 and 56. Now let us see how to sort these items. See, initially we have um the data items. See, the index are 0, 1, 2, 3, 4, 5. See, totally 6 numbers are there. 6 data items. N equal to 6. Okay. Initially, minimum index which is equal to 0. So this is the original list. And all the lists are located in unsorted place. Okay, and now we have to find which is the minimum index in this array. 8 is the minimum index. So 8 should be replaced with 23. That is the first index, right? So 8 and 23 are exchanged. See, 8 and 23 are exchanged. That is, 8 got its first right position at pass 1. After pass 1, the first index placed in its right position. And here, which is the second smallest value? 23 is the second smallest value. Okay, and after pass 2, the 23 will be placed in its right position, and 78 will comes to here. Okay, and now which is the minimum value? 32 is the next minimum value. So after pass 3, 32 will be placed in its right value. See, at every iteration, the sorted portion of the array is incremented by 1, and unsorted portion of array will get decremented by 1. Okay. See, after pass 5, all the data items will get sorted. And now let us see the algorithm for selection. See, this selection set will accept the array as parameter. So this array is unsorted integer. Unsorted array. Okay, and here we require two for loops. The first for loop, which is used to get the minimum value in its right position. At every iteration, the minimum value will get its right position. And second for loop, which is used to identify the minimum value. Okay, identify the minimum value. See, for this, we have used two different for loops. Okay, in the first for loop, initially min equal to I. Okay, this I will get min. So initially we will take 0 as the min value, and this 0 index will be verified with all the other, compared with all the other values. For that we can use the second index, that is j. Okay, if a of j less than a of min index, then min index equal to j. Okay, so here we will identify the minimum value in the unsorted bin. Once we identify the minimum value, the first value and minimum index will get swapped. Okay. See, at every iteration, this for loop, the minimum value will get its right position. Okay. The advantages of selection search. The first advantage is easy to implement and it is very easy for the beginner who learns the sorting technique. And second one, it requires very less memory space. Okay, order of n. The space complexity is order of n. And it is a table sort. That means the relative order of equal elements in the sorted array is perfect. That is, at every iteration, the minimum value will be exchanged with the first position, isn't it? In its right position. Okay, so this is a table sorting. And the fourth one is deterministic. Always it will sort the given data item. Okay, that is, it always yields same outcome for same input data set. Okay, so these are the advantages of selection sort. And these are the disadvantages of selection sort. The first one is poor performance with larger data set. That means it is suitable only for small size data, small size data set, right? And second one, it consumes more time. That is, the average temporal complexity is order of n squared. Okay, that is, if the size is increased, n is size of array. If the size of array is increased, then it consumes more time. That is, n square time it will take to sort. And the third one, absence of adaptability. That is, the selection chart fails to adjust the current element order. Okay, hence it is not suited for bigger problem. Right. So this is called as absence of adaptability. And next one, it is not suitable for almost sorted data. Okay, if the data is already sorted, then again it will take order of n square time to declare the result, isn't it? So these are the disadvantages of selection search. So far we have seen the selection search from third unit, searching and sorting. In this class we learned the selection search definition and the algorithm with examples and advantages and drawbacks of selection search. In the next class we will see the insertion search, insertion sorting technique. Right. Thank you.